Hello everyone and welcome. I am Dimitrios Gonidakis, an architect and architectural engineer representing the Laboratory of Structural Analysis and Anti-Seismic Research at the National Technical University of Athens. Today, I will be presenting a digital pipeline for regenerating the dry stone landscape of Kythnos Cyclades. Our research focuses on moving away from the paradigm of abandonment and instead utilizing a structural deterministic approach to reestablish a circular economy around traditional stone construction. To understand the value of this endeavor, we must first recognize that dry stone construction is a universal language. Over the century, diverse civilizations across the globe utilized terraced levels for landscape formulation. To survive extreme climates, traditional agricultural terraces functioned as massive passive hydrological engines. There were not just structural retaining walls, they were designed to intersect, slow, store, and redistribute the sudden violent drop pools of the winter wet season so that moisture remained available months later. Zooming into the European context, the water management of this system relies on the incredible engineering. In a natural steep, water-washed winter rainfall quickly turns into rapid surface runoff, eroding topsoil. Terraces fundamentally break this hydrological connectivity. By stepping the slope into flat horizontal planes, the kinetic energy of heavy winter rains is halted, forcing water to percolate down into the soil rather than washing the topsoil down the hill. Over decades, the retaining walls capture fine sediments, leading to aggradation, the build-up of a deep, rich soil sponge. Because the flat terrace prevents surface runoff, this deep soil absorbs immense quantities of water. The surface layer bakes in the summer sun, creating a crust that seals the lower layers, allowing deep-rooted Mediterranean crops to tap into the subterranean water reserved during droughts. This brings us to the core socioeconomic problem. In the past, there was a perfect circular economy. Dry stone maintenance protected the land, yielding agricultural production and income. Today, that loop is broken. When these systems were abandoned and the walls collapsed, the floodplains revert to steep slopes, or are steadily becoming steep slopes. The critical soil sponge is washed away by erosion and the landscape rapidly loses its ability to retain water, often leading to localized desertification. Our proposal for the future is to reestablish this circular model by orienting local economies back towards stone construction. We utilize the Cycladic island of Kythnos as our primary case study, given that roughly 70% of its land has been shaped by this terraced formation and its landscape is used as stone as primary material. The dry stone network is a comprehensive system of xerolithies, scales, and catechés. For many of us, these structures are deeply personal. A traditional stone cellar, much like the one my own grandfather constructed in Kythnos, is tangible, a living space of collective memory. These structures survive for centuries because dry stone assembles the inherently ductile. Unlike rigid mortared walls that developed fatal tensile stresses during seismic events or earth settlement, dry stone dissipates kinetic energy through micromovements. It settles as the earth settles. To preserve this intelligence against modern legislative and economic obstacles, we propose a four-stage digital management framework. We treat this wall not as a museum relics, but as active, low-carbon retaining structures. The four coupled stages are capture, assess and prioritize, restore and build, and sustain. Stage 1 establishes our foundation through comprehensive spatial mapping. We deploy professional-grade rotary UAVs utilizing high-penetration LiDAR sensor and radiometric thermal cameras. These capture the geometric complexity of these terraces, while thermal data highlights surface variation. We must remember that dry stone retaining walls also provide critical thermal mass, absorbing solar radiation during the day and slowly releasing it at night to create localized microclimates. Moving into stage 2, we process these massive point clouds using deep learning architectures for large-scale 3D semantic segmentation. We cross-reference these with localized meteorological models, while our drones capture the raw geometry of the terrain. We must remember that we are not just mapping rocks, we are mapping heritage. If you look at the cultural inputs mapped on this slide, you see more than just topography. You see windmills, chapels, traditional circular patios known as alonia, and unique coastal formation. Our spatial mapping catalogs these specific points of high cultural significance. By layering this cultural map over our structural data, we ensure that the social value and collective memory of Kythnos are directly guiding our engineering interventions. At its core, a dry stone retaining wall is a gravity structure where resistance to sliding is defined by the normal force multiplied by the coefficient of friction. The heavier the wall, the tighter the rough stone locked together. Furthermore, the true secret weapon of dry stone engineering is the elimination of hydrostatic pressure. Because the joints act as thousands of tiny whip holes, water simply drains through the masonry. Our AI-driven integration pinpoints exact zones where this drainage has failed, generating a highly targeted action plan. In stage 3, computation meets physical craft. When we restore this wall, we rely on their specific topological arrangement. We optimize the integration of through stones, which act like tension ties locking the outer face to the structural mass of the hearting, and calculate the precise inward butter required to shift the center of gravity backward, increasing the wall's resistance to overtuning moments. We also restore the rubble core, which prevents hydrostatic pressure and acts as concentration trap during the summer, dripping consistent moisture directly into the root zones. Finally, stage 4 closes the circular economy loop. It is important to note that the desire to preserve this physical craft is already alive in Greece today. We see excellent hands-on restoration work being done by collectives like Boulouki and Basada. However, they are currently forced to operate without a scalable legislative framework. Because the vast majority of these dry stone structures exist on private property, current top-down preservation mandates simple fail. To support the work of these craftsmen, our framework relies on cooperative land stewardship agreements backed by payments for ecosystem services. Subsidizing this restoration provides the missing financial structure, incentivizing landowners to maintain their terraces and generating continuous employment for these local restoration groups to ensure the techniques is passed to the next generation. In the spirit of the new European Bauhaus, these digital pipelines proves that stone can serve as highly resilient, low-carbon building material for our future. In this point, I would mention that part of this research was supported by Adapt4Seed project belonging to the Marie Sklodowska-Curie actions. Their support is highly acknowledged. Thank you for your time and your attention today.